Notes on factoring special cases, part 1. Part 1 will be perfect square trinomials. I'll do another video of difference of squares. Perfect square trinomials are when your A number and your C number are perfect squares. Don't forget, if there's no number here, this is a 1. A 1 is a perfect square. But when this is a 1, you just look at this one right here. 4, the square root of 4 is 2. 2 and 2. If we check with FOIL, we get x squared. 4, we get outside inside 2x plus 2x, 4x. It works. When you have the same binomial times itself, that is just a binomial squared. So that's how we'd write the answer. The next one, notice, let's see, there's a perfect square. The square root of 9 is 3. There's a 3 and a 3. Oh, notice this time I have a minus in the middle, a minus 6x. That means my numbers in here have to be negative 3 and negative 3. Negative times negative is positive 9. Negative 3 plus negative 3 is negative 6. The next one, and notice how I wrote the answer again. X minus 3 in parentheses squared. Hey, another perfect square. The perfect square of 25 is 5. Wait, have you noticed now that whatever this square root is, if you double that number, you get the middle term. That will let you know that you have a perfect square trinomial when A is 1. So there's that one worked out. Next one, A is not 1. But if you notice, A is a perfect square, 4 is. C is a perfect square, 9. And I take the square root of this number, 4, and I write 2x and 2x. Do the square root of 9, I write 3 and 3. I use minus signs because the middle term is a negative. I still want to check to make sure I did it right, that I do get the middle term. So 2x times 2x, 4x squared. Negative 3 times negative 3, 9. Outside, inside, negative 6x minus 6x, negative 12x. It checks. That worked, that worked, that worked. I have now 2x minus 3, parentheses squared. Let's say you didn't notice it was a perfect square trinomial. You could still do FOIL and work it out, do the big X method. So A times C, 36, the B number here, negative 6 times negative 6 multiplies to 36, adds to negative 12, divide by the A number, simplify those. My resulting fraction is what goes in the parentheses, 2x minus 3, 2x minus 3. The reason it's called a special case is these special cases follow a pattern that allows you to factor them without much effort, without doing all this. If you notice that you have perfect squares here and here, you saw the patterns that made it very easy to factor. I noticed I had a perfect square here and a perfect square here. That made it easy to just write the square root of 4 is 2, the square root of 9 is 3, and those are my numbers there. All right. Now, more about noticing the patterns. Here it is. In general, if the A coefficient and C, the constant, are perfect squares, then take the square root of each, multiply them together, and double it to get the B number. So, if 2 times the square root of A times the square root of C equals B, then you have a perfect square trinomial. Example. With mental math, the square root of 9 is 3. The square root of 25 is 5. 3 times 5 is 15. Doubled is 30. That's a perfect square trinomial. Let's see here. Square root of 9 is 3. Square root of 25 is 5. 2 times 3 times 5 is 30. So that worked, and we can write our answer. We would have 3x plus 5 and 3x plus 5. Okay. The next one, that is a perfect square. Don't forget, that's a 1. Square root of 1 is 1. Square root of 36 is 6. 1 times 6 is 6. Doubled is 12. Yes, but that's a negative there. So that means when you write your answer, make sure that you put a minus sign there. And this time, instead of writing 2 parentheses, I just wrote 1 parentheses squared. Okay, we can also see it as x minus 6 times x minus 6. And negative 6x minus 6x gives us the middle term, negative 12x. The next one, perfect square, perfect square. Make sure that the middle term does work out. If you do the square root of 4, you get 2. The square root of 49, you get 7. 7 times 2 is 14. Doubled is 28, but there's a minus sign in the middle. So our answer will be 2x minus 7 squared. Now, be careful because the middle term doesn't always work out. Look at this. We have a 1 here. There's a 4. Those are perfect squares. Don't automatically think you have a perfect square trinomial because square root of 1 is 1. Square root of 4 is 2. 1 times 2 is 2. Doubled is 4. That's not a 4. That's a 3. Actually, in fact, this one is not factorable. Don't forget that sometimes these are not factorable. What about this one? Here's another one. 1, 4. You might think, oh, I've got a perfect square trinomial. Don't automatically write x plus 2 and x plus 2 because the middle term, oh, wait, maybe this one is factorable. Yeah, how about x plus 1 and x plus 4? 1 times 4 is 4. 4x and 1x is 5x. So it's not always a perfect square trinomial unless this middle term works out, following this information up here. All right, the last bit of this notes is the general formula. Here's what you'll see. I know that looks like a lot. Let me explain what's happening here. This is the general formula you'll see in algebra textbooks. Even our CPM materials showed this in a problem. If this term in front of x squared can be written as a perfect square, and if this can be written as a perfect square, then in this business in the middle is the 2 times the square root of a squared is a, the square root of b squared is b, 2 times a times b, which is what I was showing you up here. If that's the case, then you have this, ax plus b times ax plus b, or ax plus b parentheses squared. How does that work? So if I have this problem right here, this trinomial, perfect square, perfect square. 9 can be written as 3 squared, x squared. 16 can be written as 4 squared. So 3 is functioning like the a up here, and 4 is functioning like the b up here, and we have 3 times 4, the 2 times 2 is being doubled, right? So doubled, and that's 9, that's 16, this is 24. So there it is, 3x plus 4, 3x plus 4. We could do FOIL on that to get back to that. Don't forget it also works if the middle term is a minus sign. If the middle term is a minus sign, then you have minus, minus, and a minus here. Check out this little note. The third term cannot be negative because no number times itself equals a negative. You'll never see this as a negative with perfect square trinomials. It can be negative in other trinomials, but not in perfect square trinomials. All right, I will post these notes, pictures of these notes also. Thanks. More to come.